Hey Hacksters, I'm here at Arm TechCon and we are interviewing Alex in Arm Innovator. Could you tell us a bit about what you do with Waterscope?
Sure. Waterscope are a company trying to develop a very simple and rapid way of testing for bacterial contamination in drinking water. So every day 2,000 people will die of a bacterial-related disease found in drinking water. The current system is very slow, very expensive, very complex, and we're trying to make it much simpler so that anybody can use it in any location.
Wow.
And also make it faster, so you can get a result on the same day rather than having to wait, 2-3 days.
Awesome. So when you say for everyone, often that means you start with some places and roll it out to others slowly. Where are you starting?
So we're starting with NGOs. So we work with Oxfam, we're trying to work with MSF and various other NGOs. So we see NGOs as our first customer, and then the long-term vision is to make it accessible that anybody can use it. So you want, a key stakeholder in a village in, say, Tanzania, they can do a test and they can get the same result as they would if they were in a lab, say, in London.
And it's not just anyone can benefit from it, but anyone can use it.
Exactly, yeah.
Wow.
And that's part of our mission, really. So currently, to do a test, you have to transfer bacteria through a large filter, and it's extremely complex. To transfer it, you need a 5-day training course, and we're just trying to make it automated and extremely simple.
Awesome. So can we take a look at it?
Yeah, please. So for the water testing, this is our current system. It looks much more like a product.
Wow.
So we've been developing this over the last
like
year and a half. Exactly. It's quite portable, handheld. For comparison, the existing system is about this big, right?
Uh-huh.
We just want to be able to put it in your pocket, do a test, go to another source, etc. And it's very much based on our open flexure microscope, which is developed by Richard, one of our co-founders. This is an open source microscope stage that anybody can print. You just got to download the CAD file, the STL file, which you can find on our website actually on waterscope.org.
Oh, cool.
And anybody can download it, and it's a very cheap, accessible microscope, and it's really high resolution. So the XY stage, you can move it in sub-micron position.
No way.
It allows you to actually get high resolution microscopy anywhere in the world. So we're working with a company in Tanzania where they're trying to get trying to get bottles from the skip, recycle it into a filament, and then 3D print this. So essentially, you can have a microscope that anybody can use, and you can print it anywhere, really.
Wow.
The resolution you can get from this, which is just a webcam inverted, you can get about 2 microns resolution.
Wow.
I've just put an onion cell on there, which I actually made this morning, and you can see the various parts.
Random question. I noticed these are Lulzbot colors. Are you using a Lulzbot printer or?
We're not. We just use an Ultimate at the moment. Yeah, but yeah.
So what kind of ARM technology does this use?
This uses the Raspberry Pi at the moment. It has everything we need, really.
Right. So what are your challenges in building something like this? Are there regulations that you're facing?
Yeah, there are various regulations. The hardest part actually is consistency. So second to this, we have another piece of technology, which is our cartridge, which makes the sample collection much easier.
Yeah.
And that is where our IP is, and that's where we think that's where the challenges have come from to date, really. And actually we're kind of a skeleton crew at the moment, so it's just myself full time. We have 5 other people working with Waterscope, and we find we're juggling resource at the moment, and we're trying to prepare for our seed funding round next year. Really.
Yeah. So cost is obviously an issue as a startup, and also for the consumers of your project. So how do you get the cost down on something like open flexure?
Yeah, so the open flexure, that's a bit easier, I think, than our other system, because you print it in the main body is 1 part, actually, so you print this, takes 9 hours, so it's just the cost of the plastic. And then you've got some O-rings in here and some screws. But the webcam, we buy this for $3 from China, and it means this whole system is about $10.
Amazing.
And it's really locally sustainable then, so you can actually have it in a developing country, and it's affordable, and it can be used. Whereas this one we're not focusing on cost at the moment, just because we want to make it work.
So this one is the Waterscope.
This is the water testing device, and this is our open flexure device, which we're using mainly for education, but we're trying to use it for malaria diagnostics as well. So this is a platform for expansion. So you can do many things with this, and we've got these all around the world. We've got one in Antarctica, we've got one in India, in Colombia, and they use a whole range of different things, really.
What do they use it for in Antarctica?
They're using it to look at algae,
Ah.
and to measure, look at algae movements and stuff in the Antarctica.
Yeah, so we had a contest recently for AI tech, and one of the winners was this open clean water AI, which is a similar concept but much less developed.
Okay.
And obviously you're way further ahead. But one of the challenges that he faced was just getting the yeast to like sit still and the E. coli to sit still while he's trying to look at them.
Yeah, that is a tough one when you're looking at. Lucky with algae, there's a huge amount,
Right,
which is
they're
much
just like
easier.
plants. They just sit there.
And they're much bigger actually. The E. coli is difficult. So the way we measure E. coli contamination, so we need to be able to identify one E. coli in 100 mils, which is like finding a needle in a haystack, right? So we have to have a spiking stage where you incubate them and really enhance the amount that you have, which makes it easiasier. But
can you identify it based on the shape of the colony?
You identify it based on the enzymes they produce, which change color. So then essentially you're picking up blue ones and the white ones are not relevant, and the blue ones are the ones that you want to watch out for. So it makes it easier to identify, whereas if you're identifying on shape or growth rate, it's much harder, whereas you've got clear color change. And we want that step to be completely automated. At the moment, you have to count it by eye, and you write it down on a piece of paper. We want to do it completely automated, so people don't need to worry about it.
Wow, how far away do you think that is?
We have a very basic script written by one of our co-founders, and at the moment we're just using image processing. But we might go down machine learning if we think the data is complex enough to warrant that. But at the moment, it's quite easy actually.
Did I see that it works with Python?
Yeah, it works with Python.
And OpenCV?
Yeah.
Cool.
So one of the same co-founders built a web interface which can do a time lapse. You can do autofocusing, and actually it's got OpenCV on there as well, so you can do all the image processing.
Cool. So anyone who's already familiar with those, or who's trying to learn them, could even use this as a way to learn.
Yeah, and that's on GitHub as well. You can download that, and then suddenly you've got this nice platform where people can just have a go.
And there's like a bill of materials and everything, or do people buy kits from you?
There's a bill of materials on there. We're trying to have the capacity to be able to sell them, like assembled, but we're just too small a company at the moment. But when we grow after seed funding, we'll have a platform on the website where people can buy microscopes.
So it takes a ton of dedication to start something like this and throw your life into it.
Yeah.
Obviously, you must be very motivated. Like, what's your background? Like, that helps. And
my background is it's genetics, really. So I did a PhD at Cambridge in genetics. I was looking at motor neuron disease, and I got into that because my nan had motor neuron disease, and I wanted to do something quite impactful. And I found myself becoming further and further away from what was impactful. And I was just essentially I was looking at one cell in a fruit fly for like 3 years of my life, which is important research, but it was just didn't motivate me enough. Whereas Waterscope is tangible. So we got on a field trial in January to Bangladesh, which is the large refugee camp in Bangladesh, and you really see the impact you're having straight away, actually, and that changes my perspective on what I want to do. So it's much better.
Do you feel like you'll come back around to motor neuron disease in some way, or like is this informing you?
Maybe, but academia is a really ruthless place, right? And if you don't publish for a while, you're stuck.
Do you think that's where all the motor neuron stuff is going on? Like, is there any place for like technology innovator company type things?
It's getting there. So I was in biology and then I moved to physics, where Waterscope is based in Cambridge. And one thing I noticed about the difference between physics and biology is that physics has a lot more integration of companies and corporates. So actually the pathway to spin out a company is much easier. Biology is becoming a lot more embedded with corporates, so you can there is a route for commercialization, and that will change, and that will get better and better, I think.
Why do you think physics is so much more?
Well, it's largely due to the sponsorship, right? So where I am, there's Hitachi, which there's a lab there. There's Oxford Nanopore, they have a lab as well.
Oxford who?
Nanopore, they're a very interesting company doing sequencing. They're making sequencing really accessible.
Oh, cool.
You just plug into your phone, you can sequence the human genome.
What?
It's super fascinating.
What?
So they have a little lab space, but the connection between these companies and labs just gives, I think it provides a perspective that is for commercialization. That's something I never had in my my formal education,
Yeah.
and I would have liked to know that actually there is a route that you can go as an academic to spin out a company and make a difference in a very different way. Actually.
Do you think that would have encouraged you to stay on the path that you were in?
Maybe, but
So,
again,
like,
I was doing
pros and
such blue sky research, right? That it was.
Yeah, and it's so hard to say.
Yeah,
Like,
yeah, it's hard.
Yeah. How else do you think that academia could have helped you? Like on your current path, even. Like,
Well, actually, they help us a lot right
Yeah?
now. So Cambridge
Awesome.
University really support us. So we have lab space. We're hosted by. We need a Cat IP2 lab to do bacteria testing, and to buy the infrastructure to do that as a company would be extortionate. And they really just allow us to test out what we need to know within the university.
Mm-hmm.
And they have funds. They have mentors. I've got about 6 mentors I call upon regularly. Because
so
actually
cool.
the transition from academia to business, like my mindset was very different, right? I was trying to explore everything as a PhD student. But when you're trying to make a business, you need to be very parsimonious and just do one thing.
So I can never be a business owner.
Yeah, otherwise you're wasting all the resource and you're nowhere. So, and it took a long time for us to learn that, and we had the first 6 months where we were trying to do everything, and then now we feel a bit better.
Are there any other hobbies you have that you feel like kind of play into this, or is it completely separate? Like, or is it
my hobbies are quite random. So I paint. I like drawing ships. I paint pictures.
Are you doing Inktober?
Pardon?
Are you doing Inktober?
No. And I play guitar, but it's much more to wind down, right?
Mm-hmm.
This has become my life now. So I work on the weekends, and it's got to the stage where I find it relaxing to work on the weekends.
Yeah.
Which is depressing. But it's fun. I enjoy it.
That's awesome, and you're definitely doing something that makes a huge difference.
Yeah, I think so. Yeah, and we've got a great team. The team, I couldn't do without the team. Like, as I said, my skill set is very much genetics, so I do the bacteria stuff. But we have people in the team that do optics, that do coding, do prototyping, management, and we got a great team.
Cool. Do you have a volunteer base as well?
We do, yeah, and we're always looking for volunteers. So if you go to the website,
that's openscope.org?
Waterscope.org.
Right, sorry.
Yeah. We also have a Twitter handle, which is Waterscope_org as well. And
any upcoming plans or new releases? You were mentioning about maybe raising around.
So we're trying to go for seed funding in summer next year.
Mm-hmm.
So that's very much to look at using this technology in US markets and European markets. We have a field trial in January next year as well, so keep an eye on that. So we'll post updates on our website. That's very much to test our technology in the field, see how it fares, and get partners.
And if someone wants to get involved with their classroom or some kind of educational aspect?
Yeah, just drop us a line at our website, and we'll try and get back to you. We're very short-staffed at the moment, but we'll try our best. Anything else I want to add in? Mainly just to encourage people to download the GitHub file, print them, test them out. We're trying to do a project at the moment where we work out how stable they are. So how many times you can go to the one position, to the far Y position, to the X position, etc. Yeah.
I wonder if this would be useful for people doing electronics, because I keep thinking about getting a microscope for the office for really small soldering.
Yeah, exactly.
Yeah, you think it'd be useful?
Yeah, it's super useful. So it's actually quite modular, so you can plug in different objectives. So you can, at the moment we have just a webcam inverted, but you can have a 20x compound objective, you can have a 100x. We're using this for malaria diagnostics as well. So we have a 100x oil immersion, we have a motored stage.
Malaria is smaller?
It's bigger than bacteria.
Okay.
So it sits in the red blood cell, so the red blood cells are about 20 microns, whereas bacteria about 1 to 2 microns.
Cell makes you more resistant to it because it can't.
Exactly, because it can't quite embed, and I don't know the biology there really. So we're trying to scan a malaria slide and have machine learning to pick out parasites automatically, which is, at the moment, you have one technician looking at a slide, it takes 20 minutes per slide, and it's very labor intensive.
Yeah.
So there was a lab we went to in Colombia, and there was one lady in the whole village, and she would do the testing. And she, if she was asleep, someone just knock on her door, wake her up, she'd do a test. She was ill. She was the point of call, which is lovely, but we need more testing. You need more automation. So we're doing quite a lot with this.
Well, cool. I'll definitely download this and try and get us to build one in the office, and then
Yeah.
we can I don't know if I want a machine judging me on my soldering skills, but that's a little ways down the road.
But also, what we can do is we can send you kits, right? So we have kits, and you can put them in any colors you want, and then you can just build them. So we've done a few workshops, also with Salesforce.org, and we had a workshop where we were looking at plastics in water, and they built a load of these actually.
Cool. Oh, that's so cool. Thank you so much for talking.
No, pleasure. Really good.